Welcome to Easy Gates Electrical Gate 22 paper solutions. Next problem number 18, based on a V-stone bridge. Very simple problem, playing with the uncertainty analysis, okay, or statistical error analysis. Okay, so you need to find out in which domain it is falling into. Accordingly, you need to find the tolerance of the unknown resistance we evaluate in a V-stone bridge. Okay, so he said we have a balanced V-stone bridge having the points A, B, C, and D has a following arm resistances between A to B, B to C, C to D, and D to A. We have arms of the bridge. That is given RAB given, RBC given, RCD is the unknown resistance. Okay, and RDA. Okay, then the value of RCD is unknown. The value of the unknown and its accuracy. Okay, measurement of its resistance and the corresponding accuracy of the measurement the problem is talking about. Okay, so let us form the bridge first. So between the terminals A, B, C, and D. So let this is the point A. There's a point, okay, B, let me take, and there's a point C, let me take, and there's a point D, let me take. Okay, so A to B, what we have? A to B 1 kilo ohm. I'll call that resistance as R1. Okay, A to B, I'll call this as R1. Instead of a bridge, I'll go for two potential dividers. That's also fine. 1 kilo ohm R1, I will call 1 kilo ohm plus or minus 2.1% tolerance in R1. Okay. Then RBC, B to C 100 ohm. Okay, so B to C, I'll connect the next resistor. I'll call this as R2. R2 is equal to 100 ohms plus or minus 0.5% tolerance. That's another practical resistor balancing the bridge. Then RCD is the unknown resistance. This is CD. So this is where our unknown resistance RX is. I'll call this as RX. C to D, I have RX. Then D to A, we have 300 ohms. D to A. So this is where we have 300 ohms. So call this as R4. RX is R3. I'll call this as R4. That is equal to R4 is equal to 300 ohm plus or minus 0.4%. Okay. So it will be excited. Maybe let me take this way. It is excited here. This is excited by a battery E. This is where the output of the bridge. So it is given as V0 of the bridge is equal to 0 because the bridge is in balanced condition. That's already given. Bridge is balanced. So we have the principle of a balanced bridge. The principle is this: product of opposite impedances. If it is AC, if it is DC, simply product of opposite resistors are equal. Okay, when the bridge is said to be in balance. So I can write the balance equation as Rx into R1 is equal to R2 into R4. Rx into R1 is equal to R2 into R4. But this I will find. I'm using the nominal values of known R1, R2, R4 to get the nominal value of Rx. So the unknown nominal value of unknown is this. It's R2, R4 divided by R1. I'll find the nominal value. So Rx is equal to, what is R2 given? 100 ohms into R4 given 300 ohms divided by R1 given 1 kilo ohm. So let me take it as 1000 ohms. Okay, so ohm square ohm will get cancelled. So numerator is going to be 30,000 divided by, so let me eliminate necessary zeros. So 3000, 3 zeros, 1, 2, 3. Okay, so that means Rx is going to be 30 ohms. If that is only available in only one option, we can complete the problem with this itself. Okay, that's a nominal value of the unknown resistance. Okay, interestingly, we have two options. Okay, so it seems to be these two are okay. So which one is okay? So we have to determine the tolerance only. So based on the tolerance, we'll decide what is the right choice. Okay, so what is the resultant? We have deduced Rx is equal to this. Okay, so what is Rx? Rx is equal to, we got the expression Rx is equal to R2 R4 by R1. So let me take that R2 R4 by R1. Okay, yes. Now I have something similar to this. Okay, so y is equal to AB by C. So then if you go by uncertainty analysis with the tolerances given for A, B, and C, then we can prove that delta y by y is equal to delta A by A multiplication or division. That's a resultant. That's a property we have to exploit. With that, the problem is very easy. Okay, delta A by A, delta B by B, plus delta C by C, and put everything in percentage. That's a percentage change in C, percentage change in B, percentage change in what? A. That is the resultant percentage change in Y. So this is resembling something like Y is equal to AB by C. Therefore, delta Rx by Rx, the percentage change in Rx will be this. That's unknown, is equal to delta R2 by R2 in percentage plus delta R4 by R4 in percentage plus delta R1 by R1. Since it is in denominator, we are going for the absolute maximum deviation, remember? So percentage. As per the error analysis, this is absolute maximum deviation. So absolute maximum error also we can say. Therefore, the error in tolerance in unknown resistance RS is, in percentage is equal to this. What is the percentage? So R2 percentage is given. Who is R2? This is R1 for us, and this is R2 for us, and this is taken as R3, and this is taken as R4. Yes, just take the tolerances. R2 having a tolerance of how much? Okay, anyway, simply we need to add the tolerances, but anyway, I'll go with that. Okay, what is the R2? 0.5%. So there's going to be 0.5%, of course, plus or minus. Okay, 0.5% plus R4 is having 0.4%. So it is 0.4%, and this is having R1 having 2.1%. You just add them. So the net percentage is going to be 2.1, 0.4, and 0.5. So designer is helping you. So the net is going to be plus or minus how much? 3%. Okay. So therefore, how to call your Rx? So Rx is equal to, already you know the nominal value, that is 30 ohms. So 30 ohms plus or minus what? The variation, percentage variation. So 30 ohm plus or minus 3%. Okay, so what is 3% of 30? So then it is 30 ohms plus or minus 3 by 100 into 30 ohms you will get. Okay, so 3 by 30 is 90, 90 by 100, 0.9. So the best possible answer is 30 plus or minus 0.9 ohms will be the tolerance. 0.9 ohm will be the tolerance. So that is your unknown. So the nominal value of the unknown and its measurement error because of uncertainty or tolerance in the practical resistors R1, R2, and R4. Okay, that's a simple and interesting problem exploiting the fundamentals of error analysis. Okay, and hope you enjoyed this content. Okay, do subscribe the channel and look for the updates.